Hi friends, this is Syed Reshma Sharif. In previous video, we discussed about discrete Fourier transform as linear transformation. Okay, by using discrete Fourier transform equation, x of k is equal to summation of n is equal to 0 to n minus 1 x of n wn to the power of kn. Okay, where the values of n k ranges from 0 to n minus 1. From this linear transformation, we are going to represent this in a matrix method. Okay, here we are taking k is equal to value 0, k is equal to value 1, k is equal to n minus 1. Okay, from these we have to write all the values of a matrix method. The matrix we need to write Wn values. We have to note, first of all, see Wn values. All those are Wn values from the first row. Wn value is 1. Okay. Let us write it in a matrix method. The matrix will be x of 0, x of 1, x of n minus 1. For this, we have to write the matrix method by using the Wn values. In the first row, Wn value is 1. In the first column, the Wn value is 1. First column, the Wn value is 1. Okay. In the second row, the Wn value is Wn. And similarly, with the Wn, at n minus 1 column, the value of Wn is Wn power of n minus 1. Then, in the same way, at the second column, we have to take the values of 1, Wn to the power of 2, Wn to the power of n minus 1 into 2 up to for first row it may be 1. For second row it would be Wn to the power of n minus 1. In the same way, it would be Wn to the power of n minus 1 into n minus 1. Okay, by multiplying both sides with x of 0, because it is a common in all columns, x of 0, x of 1, x of n minus 1. So in both sides, we have to multiply with x of 0, x of 1 up to x of n minus 1. Okay, these are both sides, it will be similar. The matrix is n by 1 matrix. This one is n by 1 matrix because n rows and 1 column. This one is n by n matrix. N number of rows, n number of columns. This one is n by 1 matrix. Okay. This is the matrix representation with n number of rows and one number of column, n by 1 matrix. Here this one is n by 1 n matrix. This one is n by 1 matrix. Okay. Symbolically, this can be represented as written as x of n is equal to wn into x of n. This one is an equation 1. By using this equation, you can find out the discrete Fourier transform of given sequence. Let us pre-multiply by Wn inverse. It is a inverse. Remember that Wn to the power of minus 1, it is not an inverse of Wn. We have to multiply it with Wn to the power of minus 1. It is just a symbolic representation of an equation of inverse discrete Fourier transforms. Okay. Then Wn to the power of minus 1 x of n is equal to Wn to the power of minus 1 into the power of x of n. Okay. Whereas Wn to the power of minus 1 x of n is equal to get cancelled. This one and this one will get cancelled. Then x of n. X of n is equal to Wn to the power of minus 1 x of n. This must be an equation number 2. We know that inverse discrete Fourier transform that can be written as, that is given as x of n. Inverse discrete Fourier transforms. X of n is equal to 1 by n. Summation of n is equal to 0 to n minus 1 x of k Wn to the power of minus k. This is inverse discrete Fourier transform. Okay. That is 1 by n summation of n is equal to 0 to n minus 1 x of k Wn to the power of kn star. It is a complex conjugate because we have a negative term. Complex conjugate. Okay. Then it can be written as x of n is equal to 1 by n x of n Wn complex. It may be an equation number 3. By using this inverse discrete Fourier transform of given series, we can compare equation 2 and equation 3. Then it can be written as Wn to the power of minus 1 is equal to 1 by n Wn complex conjugate. This is about the discrete Fourier transform as linear transformation. It is not a difficult. First of all, we have to identify all the values of a. By using this matrix form, the returning writing an equation, it become very easier. Okay, first of all, we have to note all the values of Wn, where the places of x of 1, x whereas x of n minus 1. Okay, we have to identify from all the equations from we are going to add in discrete Fourier transform equation by substituting all the values of 0, 1 up to n minus 1. So it can be a IDFT sequence. This is a complex conjugate. This one is an inverse discrete Fourier transforms. Okay, for the given sequence. This is a linear transform of the given sequence. Okay. Thank you for your watching. If you have any doubts regarding this, please comment me on my comment section.